Okay, great. So yeah, welcome to Cloud Native Live. So where we dive into the code behind Cloud Native. So I'm your host Sharir Mustaqim Mithil. So you can call me Mithil Sharir as a whole. So I'm a Sensitive ambassador. So and every week we bring a new set of presenters to showcase how to work with cloud native technology. So they will build things, they will break things, and they will answer your questions. So in today's session, I'm stoked to introduce Suvarna and Yusuf, who will be presenting on From Cloud to Code. Okay, so this is an official live stream of the SaintSafe. As such, is subject to the SaintSafe code of conduct. So please do not add anything to the chat or question that would be in violation of the code of conduct. So basically, please be respectful to all of our fellow participants and presenters. So with that, I will hand it over to Yusuf and Suvarna. Let's add both of the speakers. So yeah, hey Suvarna and hey Yusuf, how are you guys?
Awesome. How are you, Mithal?
Yeah, I'm fine as well. So yeah, it would be great if you guys can start like introduce yourself and then we can start the session, right?
So, good morning, good afternoon, good evening. I am Yusuf Kachwala. I am a founding engineer at StackGen, and I have around 13 years of experience, around 5 or 6 years of experience with Kubernetes, cloud native technologies, distributed systems, architectures. I'm a tech evangelist, and for the last few years, I've been working in the security domain, cloud infrastructure security. An open source tool called Terrascan. And yeah, today uh, I am stoked and very happy to be here.
Yeah, awesome. What about you, Shubhana?
Yeah, hello everyone. Swarna here. So I am software engineer and have 6+ years of experience in software industry. And from last 5 years, I'm working on the cloud technologies. Previously, I was working in the security part of cloud, and I'm also working on the deployment and infrastructure layer. So yeah, I'm also maintainer of that open source tool that Yusuf mentioned, Terrascan. So yeah, happy to hear. This is my first live, so I'm happy. Thank you.
Awesome. So let's start the session, right? Okay, let's go for it.
So today we are going to
Uh,
discuss about.
Wait a bit, Yusuf. I believe Subarna, can you please share this screen?
Yeah.
Yeah, this we're done. Yeah.
Okay. I have
Okay.
started my screen share.
Yeah,
Hope.
we are good to go. Go, Yusuf. Yeah, let's go.
Thank you, Mithil. So, guys, today we are here to discuss or talk about managing growth with infrastructure as code, from cloud to code. But before we discuss about that, let me ask or start with a question, right? How many times have you come across on your company or on your company's cloud console, whichever you're using, resources tagged or labeled as "do not delete resources" or labeled or tagged with tags like critical, customer POC, test DB. Uh, so and nobody knows why they have been created, nobody knows the context, why do not delete it, why they are critical, uh, why they are, which customer they are which customer POC is going on. So there is no trace of such resources, and most of the time such resources pop up because someone manually provisioned a resource in cloud just to save time or to do some quick experiment or to fix some urgent issue real quick without spending a lot of time on process and just trying to fix, right? So somebody has manually provisioned those resources. Now when I mean manually provisioned, it either can mean that the user has gone into the cloud console and clicked his way through the creation of the resource, or he has used the cloud CLI to create that resource. An example would be like if you're trying to debug something on a server which is not accessible to the outside world. Typically, a user creates a Bastion server and then SSH into the Bastion server and then logs into that server to do some debugging. Right. I remember when I was a junior engineer, I had added a firewall rule and as an urgent fix, and I had not documented it. And what happened is, a couple of months down the line, a colleague of mine cleaned up that role as a part of the cleanup, the regular cleanup. And guess what? Like, all hell broke loose. I was trying to shove my face away from that meeting, and I was trying to make sure that uh, I regret that, right? So
Yeah.
it is very common to provision your resource manually when you're trying to do something very quick, or it is also very common where you are in an extremely high-paced development environment. For example, you are in a organization which is delivering features at lightning speed, more and more features, which means that the cloud infrastructure is evolving those with those features, right? Now, uh, this is exactly what happened with one of our customers, right? So there was they had such huge pace of delivering their features that they opened up the dev environment to their developers and engineering teams. So the whole engineering org was creating resources in cloud, right, left, and center. And that's how those resources popped up: critical, do not delete, test database, customer POC, and whatnot, right? And those guys wreaked havoc in the cloud environment. The resources spiraled out of control, so did the costs. And the higher management came to, came to the understood the severity of the situation when they saw the cloud bill. That's the time the big guys come in, right? Saying that, oh, why is the bill so high? So what happened was, as a first step, they shut down the access for all the engineering teams and just allowed the DevOps teams to have access to all their environments. Now, the DevOps teams was very lean with very less number of DevOps guys in that. So what happened was, the whole pressure to keep up with the feature request on cloud came to those poor people, right? Now, what happened was, even though they were following processes, just with the sheer volume of requests that was coming to them, for small fixes, they started creating resource manually in cloud. So, for example, their application was initially requiring only read permission on some blob storage, and then as the application evolved, it required write permissions. So now these guys were not creating IACs to update the permission; they were going in the cloud console and updating the permission. One of the instances was that they had a new serverless application coming up, and they did not have a serverless IAC template created in their pipeline. So they had to actually provision it manually, right? So this is how the whole manual provisioning thing works, right? Nobody wants to do it, but inevitably it happens, right? So as we talk to most of our customers, and as we see, observe, even if you have very good processes in place, there may be some resources that leak into your prod, right? So not in prod, but in your cloud environments. So that is how it works, right? And as we are talking about manual provisioning, I talked about a term, something called as IAC, which is infrastructure as code. So that is the more pronounced, correct way of deploying your infrastructure in cloud. So you basically codify infrastructure as code. So you write the code to deploy your resources in cloud. So you basically codify your configurations for your servers, your databases, and all the resources, the networking components in code, and then use that code to deploy. Now, the Kubernetes ecosystem is excellent because everything is ISA. I mean, you can still do a kubectl run and directly create pods, but most of the deployments in the ecosystem happens through a spec file. Either you create a deployment spec, or you create a spec for a cron job or a job. That's great. That's not very much true for cloud infrastructures, right? Like, and there, with increasing awareness of IAC, people are resorting to IAC processes, but there are always some resources that trickle into your cloud environments. And there are a lot of IAC tools, like the OG tools like Chef, Puppet, Ansible, and the new generation of tools like Terraform, Cloud Formation Templates, ARM, CDK, CDKTF, and the list goes on, right? There are advantages to manual provisioning. You can quickly fix your issues quickly. It has a very less turnaround time, but it has a huge downside. It is prone to human error, difficult to track changes, and often leads to security concerns and security vulnerabilities, because you can manually open a port, an unsecure port in the cloud, and it remains there because you've not documented it, right? So there are lots of downsides to manual provisioning. Whereas when you go to infrastructure as code, or you adopt infrastructure as code, the there is some setup cost required, where you have to learn the syntax of the code that you're trying to write. It requires some setup, but it has a lot of advantages. It brings in consistency, standardization, ensures that your configuration is consistently replicated over environments. If you want to create a new site, or you want to deploy your application to a new region, it brings in scalability and efficiency. Version control, so every most of the times your IAC codes are checked into your Git repos, and it has a commit history, so you know which commit, why certain changes are being made to the infrastructure. Reduced risk of human error, so you're not opening ports on in your IAC code. So basically, security threats and vulnerabilities are not do not creep in when you're writing IAC. Also helps you with a large team, with improved collaboration. So if there are a bunch of engineers trying to make changes to the cloud, then it brings a good sense of collaboration in the team. So now we discussed the manual provisioning part. We discussed the advantages of IAC. Now the question comes: what if I want to bring some or all of my unmanaged manual resources deployed in cloud under IAC control? So, so how do you do that? There are a bunch of tools available that can help you do that. So today, what we are going to look at are two open source tools. One is OpenTofu and Terraformer, and these tools help you regenerate the IAC, and the IAC which we are going to use is Terraform. My friend and colleague Suvarna is going to demo these tools. Over to you, Suvarna.
Yeah. Okay. Thank you so much, Yusuf. That was great. Thank you. It was great. You explained it awesomely how the cloud resources are provisioned manually, and how that creates and have a later point of time. And as we now know that the solution is IAC, but now we will struggle finding the tools which will help us do that thing. So our community has built a support of various tools to do that stuff. So
Hmm.
uh, for this demo, we are majorly going through two tools. One is OpenTofu, and then there is Terraformer. So they have their own pros and cons and ways of importing those resources and bringing them under IAC control. But let's try them out, and then we can discuss around that. So before even going and doing the import, I'll go through the documentation, and then we can go ahead with the demo. So I'll first go through the OpenTofu documentation. So this is the OpenTofu GitHub repository. Okay, it has everything, all the details and all. And then there is also an OpenTofu documentation with installation guide and proper documentation, explaining why OpenTofu, what OpenTofu does, and everything. It also has a installation page with all the flavors that are available currently for the operating systems. So depending on your open operating system, you can go with one of the installation uh, link. So since I'm on Mac, I'm using Homebrew, and for this demo I've already installed OpenTofu on my machine. So yeah, so without wasting time, let's try and the OpenTofu import. So I'm I hope my VS code is visible. So yeah.
Yes.
Okay. So before trying the import, let's review the command that OpenTofu provides, the version I'm using, so that uh, it will be relevant to this version. So let's try the version command. Have version. So this is the version per OpenTofu. This is 1.8.6, and this is latest and greatest for my knowledge. And if you must be wondering why I'm using tofu, the CLI shortcut or CLI command for OpenTofu is tofu. So you'll be using short and simple command, that's tofu. So I love that word tofu. It's short and I can remember it quickly. So let's review what all commands tofu supports. So here are all the commands that OpenTofu supports. It's um, uh, all general main commands for init, validate, plan, apply. But for this demo, we are going to use the import command. The import is the command which will help us to bring our cloud resources that are provisioned manually under IAC control. That's what we are demoing today. And this is the command. It also have a short description saying that associate existing infrastructure with OpenTofu resources. It's if you have worked with Terraform, you must know the TF files and the HCL syntax. So it brings all those resources in that HCL syntax itself. So let's actually start that using that import command. So for OpenTofu to do import process, it needs some prerequisites. It needs few configurations, few uh, declaration before actually starting the import. So for that, I'm creating one directory so that I can have everything under that folder. So tofu demo and cd to tofu demo. So here in the tofu demo, I'm creating one main.tf file. So for tofu to work, it needs the resource declaration. So it basically works like whichever resource you want to import from the cloud, you'll have to provide declaration of that resource. It may be an empty declaration, but it needs that declaration. That's why I've just created this file, and I'll add the declaration in this file. So adding the declaration for this demo. I'm have created few S3 buckets in my AWS manually, and I'm just trying to bring them in IAC control. So I'll just use AWS S3 bucket for example. So I'm naming as it as demo S3 bucket. So as I said, it just need the declaration. You don't have to worry about the configuration right now during the import. So I'm just keeping it as blank. Then I'll also add a provider .tf. Just that OpenTofu needs few plugins and packages are present on your setup to perform the import. That's why I'm just adding the provider so that it can fetch all those packages related to that particular provider. So yeah, provider is AWS and my region is AP South 1. So uh, yeah, the prerequisite is done. All I've created all my TF files. I'll now try to do the init tofu init. To as I said, it needs few packages. The init is the command that will bring all those packages. I'm just starting the init process. Oh, for your information, I've already set up all my credentials and everything in environment variables. Basically, I'm using AWS for this purpose, so that's why I have set up my profile and region in the environment variable. It will differ for GCP and Azure. It may be something different. For GCP, it may be a service account, and for Azure, it may be subscription ID, tenant ID, something like that. But for AWS, it is uh, the region and credentials. So I've already did that setup. So the init is done. So let's start with the import. So tofu import AWS underscore S3 underscore bucket dot the name of my module or resource, then the address of the resource that I created in cloud.
So Suvarna, this bucket, delete SR bucket, is already created in the AP South 1 region,
Yes,
and you're trying to bring that bucket under ISA control, right?
Yes, exactly. I'm doing that. So, as you were mentioning, if, have you seen any bucket name delete or POC? So, for this demo, to make it uh, uh, so, uh, so everyone to aware this kind of buckets get created or this kind of resources get created, I've just created that. So, if you haven't seen some resources like that, I have one for you. So, for this demo, I've created S3 bucket manually with delete as the prefix so that I can delete it later if I keep it in mind. So yeah, this is the bucket that I have created manually. So I have just done typing my import command, but let's actually read through this command. What does this command means and how it executes? So tofu import, then the AWS S3 bucket. It requires you to provide the resource type which you want to import, and the destination of resource, that empty block that you have added, the name of that destination where you want to actually import that cloud resource, and the address of your cloud resource. Like if it is S3, I have provided a name of S3 bucket. If it is Athena, it may be its ID. If you, VPC, similarly it can be ID. So it depends on what resource you are trying to import. So this is how the command has been read. So let's start the import.
So,
So
the resource type, right? AWS underscore S3 bucket. The tofu resource type and the cloud resource type is something the user have to figure out themselves, right?
yeah, that's usually if we go through the documentation of Terraform or OpenTofu, all these things are there, well documented. We can take a reference of that. But yeah, the AWS S3 bucket is tofu resource type, and then the other resource, that cloud resource, the address you have to provide, you'll have to figure it out on the cloud itself. So the import is done. Wow, the import is done already. Till I was just answering that question, the import is done. So let's review what was the output of this import. So here you can see there is a TF state file that got generated through this import, and let's quickly review what I have through this TF state. So here you can see I have a resource of type AWS S3 bucket. Then this is the name or of my module that I provided in empty declaration, and then there is the all the configuration that I did manually on cloud is present over here in the TF state. You can see there is also a tag called a CNCF demo. So for this demo only I've added this tag. I know this is not a good way of tagging resources, and I would suggest not to use something like this because it will cause problems in to you in future. But for me it's okay because I'm using it for demo, and I wanted to specifically uh, specify this is the resource actually I created, and it got imported, so that's why. So this is the resource. So yeah, right, it's awesome, right? We got our S3 bucket that was manually provisioned under IC control. Right, but you must be wondering, is it really under ISC control? Would it be like if I update something in this S3, it will get changed or updated on my cloud? Actually, no. You'll have to do some manual steps actually to make it and bring it under ISC control. Let's go to that main.tf file. So we have that main.tf file created with empty declaration. So you will have to just provide the configuration over here again, and then so this was actually, this is not the bucket name. It was delete sr bucket, and whatever new configuration you want to add you can just specify over here, and then you can go ahead and do tofu plan and apply, and it will just update the existing bucket with all the changes you want. And yeah, now going forward you have a control over that bucket through this ISC files only. So yeah, it's great, right? uh, there are few shortcomings of OpenTofu. Like it works very well with single or individual resource import, uh, because you have seen it requires some files or some declaration beforehand before the import process starts, like the S3 declaration I did. So if you have a bunch of resources, thousand resources or something like that, then you'll have to provide declaration for all those resources. Then the command also need you to provide the resource type. So it bit confusing and as well as cumbersome to do all those things. So yeah, so actually it differs from use case to use case. If you are just importing few resources, then this is an awesome tool, you can use it and get done with your work. And but if there are multiple resources, you may have to find something different, some other tools. But yeah, for now it's good. Like I feel it's doing a neat and good job of doing importing one resource at a time. So yeah, we are done here with the OpenTofu import demo. I'll pause for a minute to take questions if there are any.
I have a
Yeah.
question if there are no questions from the audience.
Yeah, we are open for the questions, right? So, folks, if you have any questions, feel free to ask. It's your moment, right? Yeah, Yusuf, you can ask the question.
So, Suvarna, you talked about how difficult and tedious a task it is to bring one resource at a time. So, if I have got large number of resources to be
Hmm.
imported, what's the way ahead?
As I said, there
That's
is
good.
another demo coming up, so you'll get the answer. So wait for that. This, as I
Yeah,
said, this is for one use case, depending on number of resources. But we have other tools also for bulk import use cases. Yeah. So I guess all of the viewers want to go with the bulk import use case. Actually, that
yeah.
then I will answer
Let's go for
ask
that.
questions. So let's go to
Yeah,
that.
let's wait for that. If there are questions, they will pop up, but let's continue with the
Yeah.
one.
So as I said, OpenTofu does a good job of importing individual resources, and as you Yusuf was eager to know about other tools that can fulfill the use case of importing bulk resources. So yeah, we have multiple tools that are community built for us already. So we are going to go walk through one of such tool, which is Terraformer. It's an open source tool, and I'm already on the documentation or a repo of Terraformer. Here is the Terraformer repo. You can see it has all the documentation, readme. There is a demo, also short demo video also available in the repo. There is an installation guide as well present. So here is the installation guide. You can it also supports multiple flavors. If you are on Linux, go you can follow this instructions. For Mac OS there is different instructions. For Windows also there is some steps to be followed. So it has all the flavors currently supported, so you can go with one of them. For my use cases, as I already mentioned, I'm on Mac OS. I have already installed Terraformer using Homebrew. So let's actually start with the Terraformer demo. Okay, I'm back on my terminal. That's what I do. So okay, let me just switch back to my main folder. So before actually doing anything, as we review the OpenTofu commands, let's review Terraformer commands as well. As I said, I was loving the tofu command, which was short. In case of Terraformer, I just hate to type that long command, and I'm just bad with the spellings, and I always do typo. So it, bear with me. So I'll just check for the version. Okay, so this is the version right now on my machine. It's latest one, 0.8.24. Let's review what all commands Terraformer supports. So it majorly supports two commands, that is import and plan. So the import is the command which helps us to bring multiple cloud resources under ISC, and then there is also a plan way of doing things. But we, for this demo, we'll be majorly going to the import command. So let's review what all sub flags are present under the import command. Okay. Oh, lots of sub commands present. So if you have seen this, then you'll know that this is all cloud providers that present. And so any number of cloud providers out there, it supports all of them. You can see Ali Cloud, AWS, Azure, then Google, all of them are here. So you can import any cloud resources to IAC. So it has support for all of them. For this demo, I'll be going with AWS only. So let's start with the actual import process. So let me create a directory for this also, because there, that way we can differentiate between the outputs. Okay, so I'm in the Terraformer demo folder. So as Tofu needed few prerequisite initial setup files, Terraformer also needs a file, or it needs actually packages and plugins available to do the import process. For that, I'm just adding a provider TF, that the ways I added for Tofu. So I'm just adding provider as AWS and region as US, as AP South 1. So I'll just quickly do the I'll quickly do the init so that I can get all the packages and everything downloaded on my machine, so that I can use that for import process. So yeah, let's give it a minute so that it can bring all the packages. Yeah, so I have all my packages present. Let's start to actually write the import command. So I have already created few S3 buckets, and I'll be just pulling those S3 bucket under my IAC. All of those S3 bucket I have created manually, so for this demo only. So let's start with the command terraformer import, then AWS, then hyphen resources equal to S3, then hyphen region is AP South 1, then hyphen profile demo. So I have multiple profile accounts, so I've just profiled them and I'm using one of the profile demo. So I've done with the command, but let's actually go through the command, how it works, or what the command means. So it is basically terraformer import, then which cloud, that it is AWS, then what all resources. I want an S3, so that's why S3, and then from which regions, so that's why AP South 1, then which profile you want to use, so I want to use demo. So these flags are very specific to AWS. If you are using Azure or GCP, these flags may change. It depends on the cloud from which you are importing. So for GCP it may be something different, like subscription ID or something, resource group maybe, or location. So for AWS, it's region and profile. So let's start the import. So it will take few minutes to bring those S3s. It actually, I only have two S3s present currently on my cloud. That's why it did its job that quick. But if there are number of buckets, like 1,000 buckets or 100, it will take few seconds or 2 minutes, depending on the number of buckets or resources present. So I'm just making this clear that because this is only two bucket, it happened that quick. Else you guys will come back to me later saying it is taking that much of time. So it will take. So let's review the output. So so if you can see, it created one folder called a generated. uh, yeah, Terraform also provide an option to provide the name of this output. For now, I haven't provided. That's why it use its default name. So here also you can see there is a TF state file that got generated. Let's review content of this as well. So here you can see it followed the module structure. It's more enriched than what we had in OpenTofu. It also has some output declaration, resource declaration. There are two buckets. One is delete SR bucket. Also, you can see it just created some default name for my this S3 bucket to import. There is another bucket also. So yeah, it was successful to bring all those S3 bucket. In addition to that, you can see there is an module S3 module files that got created. So yeah, it also creates the resource declaration. You can see. So in OpenTofu, we had to ourselves write those configuration, but here it provided relief with that activity of writing those configuration by our own hand manually. It is automated, so you can just use it if you want to variabilize or whatever. You can do it, but at least it provided you the declaration. So you have all the static declaration provided over here in the module structure. So awesome, right? But as I said, there are few shortcomings with Terraformer as well. Few things are repetitive, like if you have seen the hyphen region and profile thing is needed again as a flag, though I have set up it in environment variables. Then understanding the command itself is bit time consuming and difficult, because the documentation does not cover all the examples related to all the resource type. But yeah, it does a fair job of doing the import, uh, though it is doing some stuff, but writing variables and finding all the relevant configuration for this resource is difficult. Uh, it is not following the latest and greatest version right now, so that is also one task. But still, it is giving something that we can just be happy about. Right now, I'm happy. So yeah, that is pretty much about Terraformer that we have for demo just now. So again, open for questions. Before any other questions, I'll like to know from you, so that is your question answered?
Yes, it was answered. Thank you so much. It was an awesome demo, Suvarna.
Cute.
Hmm. So yeah, mm, like after the session, make sure that you delete the buckets, right? As you mentioned. So yeah, that's the thing. Okay. So yeah, we're expecting questions, but if not, like, uh, let's wait for like 2 to 3 minutes for the questions. If there are no questions, like, we can just talk about like, okay, how we got into it, or what are the pros and cons about it. Maybe something you can share about it, like what are the cons about this thing.
Yeah,
Yeah.
Suvarna, you again once. Yeah. So before I go into the pitfalls and challenges, I'll just say there is a passing note that there are bunch of tools available. We just looked at two of them, right? uh, there are tools. There is a tool called Former 2, which is a UI based tool, so you don't have to manually type everything like Suvarna was doing for her demos. There are other tools like Terra Cognita, AWS to TF. So there are cloud specific tools, AWS to TF. There is a Azure specific tool called AZTF Export, right? So you have to be careful in choosing the tool that you are for your particular use case. Uh, Look at how well maintained the tool is. What are the recent and the latest support that are coming out? Is your tool supporting the latest version of the IAC that you are trying to use? Does it have good resource support or not? So there are a bunch of tools over that. You have to do some homework and some research. But all of these tools have some challenges and pitfalls. Like the generated code that we saw, right? They had absolute values. So you cannot reuse that code for replicating that environment. Like the bucket name over there was actually an actual string. In an actual Terraform, it's a variable. So you have to manually go to the generated code, take a look at it, and then add variables to the attributes that you require them to be variabilized, right? Similarly, if there are no cross references, which means that for an example, when you manually write the Terraform for creating a VPC and subnet, the VPC ID is cross referenced inside subnet. You do a cross referencing over there. You do not give absolute VPC IDs because the VPC is not yet created. How do you give, right? You use cross references. Now in the generated code, subnets will have all actual IDs over there, right? So you'll have to go through again, depending upon your use case, create those cross references manually. And the most important part is you may encounter security gaps in the generated code, which I mean that if somebody has accidentally opened an unsecure port on your security group and you've regenerated the Terraform, it is going to introduce that, bring in that unsecured open port in your ISE as well, which means that before you actually start reusing, creating more environments out of it, you will have to, you know, do a security check, maybe use a tool like Terrascan or TFSec or Checo or whichever. There are a bunch of tools that do a security audit of your ISE code. Then, if your task to do a cloud to code migration is to clean up the excess resources which are there in the cloud, you will again have to go and take a look at the code manually. There is no visualization which immediately gives you an indication of what resources are created outside of IAC. There are a bunch of problems that we discussed. Um, uh, there is so StackGen also has an offering which actually solves all your problems. Uh, but now let's discuss the best practices and strategies to bring your unmanaged cloud into IAC, right? So the first thing that I would like to clearly say is that this is a very use case specific, dependent activity, right? So for example, you have already a lot of IIC being written, already written in your organization, and most of your resources are getting deployed through IIC, and there are a few resources that are already are deployed manually, and you want to bring them under IIC control. Then probably OpenTofu import is the best way because it just fits right into your existing IAC code for structure, and then it works seamlessly. If you have a large number of unmanaged resources in cloud and you want to bring them back, you can use any of the tools, Terraformer, and there are a bunch of tools, right? But uh, it would always be a good idea to start importing the non-critical resources first. See what the tool generates, the output is compatible, or how good is the output. Is the tool generating the output that you are expecting it to generate? And get your, make sure that you get well versed with the tool and its outputs. If you're trying to bring applications into IAC control, like so there are, let's say that there is a e-commerce application and has a cart service with a bunch of resources deployed. Probably what you can do is go and add correct tags into all of the resources for that service, and then import by tags. So all of these tools support import by tags. So you can specify the correct tags, and only those resources which are dependent of which are you know uh, under the application that you are trying to import, then would basically be imported, right? And once you are done with this, then probably you can think of bringing your more critical resources under IAC control. that your databases and your secrets and whatnot, right? Or again, a note of caution: always run some security scanner on the generated IAC. Take and address the pitfalls and the challenges that we discussed in the last slide: variables, cross references, everything. Correct. At last, on a closing note, I would just say that migrating cloud infrastructure to IIC is just not bringing. It's not just about automation or bringing your cloud under IIC control. You actually have a purpose. You want to make your infrastructure secure, reusable, and at the end make it scalable, right? So that you can replicate those environments very well across regions and sites. So with that, you know, I would say that if you are in your process of migrating unmanaged resources to IAC, and you want to share your experience, or you want to discuss it with us, feel free to reach out to us. We are open to sharing our experiences with similar journeys with you, and looking forward to help you out. Otherwise, also, if you have any questions, any queries that you want to reach out to us, feel free to reach out, right? And with that, Mitul, uh,
Yeah.
I'm handing it back to you.
Yeah. Awesome. So we can see the screen, right? So yeah, you can just reach out, like, right? So yeah, great. So I can't see any questions though. I believe maybe like it's late night here as well. So many folks. Yeah. So yeah, no issues. So yeah, thank you so much, guys. Yusuf and Suvarna for an awesome time. We had a really awesome time, like learning a lot of things, right? So yeah, I think we can end our session, right?
Yeah.
Okay, so yeah, thank you so much, guys, and hope to see you guys soon, right?
Thank
Okay.
you.
Thank
Bye.
you, guys. Take care.
Uh,
Bye.
so yeah, that was Yusuf and Suvarna with us. So yeah, thank you so much. Thanks everyone for joining the latest episode of Cloud Native Live. So we enjoyed the interaction and questions from the audiences, which was not today, but yeah, we had our questions as well. So okay, thanks for joining us today. We hope to see you